This is the third video on this topic of solving quadratic equations. In this last video, we will discuss the pre-calculus algebra topic of solving quadratic equations using the quadratic formula. To start with, it's important that you know that quadratic formula. There's not a lot this semester that you'll need to memorize, but this is one of the things you'll need to memorize. Now, applying the quadratic formula or any formula, here's some steps that I'm going to encourage you to use. The first step is to actually write the formula. And I do actually mean to write that quadratic formula each time you're going to apply it. The next step is to write the values you know. So write the known values. So in this case, it would be to write what A, B, and C will equal. And then the third step is going to be to fill in the known values into the formula. And then the last step is going to be to simplify. And that's how you would solve. Now to start with, when we're looking at a quadratic formula, or a quadratic equation rather, notice that the coefficient of the x squared term, that's labeled A. The coefficient of the x term, the linear term, is going to be B. And the coefficient, or not the coefficient of the x to the 0 term, or in other words, we could just think of it as the constant, is going to be C. So in our problem, we can see that A is 3, we can see that B is -3, and we can see that C is -4. So the first step of the problem, I'm going to write the formula. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. If you haven't learned that before, or if you've forgotten it, please make yourself a note that you will need to re-memorize that. But then this next step is I'm going to write out what A, B, and C are. Again, it's not just what order they come in. It's what order they come in when they're in this descending order. So we've got to have the x squared first, and then the x, and then the constant. So the A is a coefficient of that x squared, B is a coefficient of x, and C is the constant. And I didn't say this as we started, but notice that we do have to start by setting it equal to 0. Next, I'm going to write out this formula again. Watch what I'm going to do here. I'm going to write the opposite of B, but I'm going to leave the B as empty parentheses. And then B squared, again, empty parentheses. Minus 4 times A times C. Some of you are beyond needing to do this step. If you're getting this correct every time, none of that business of, oh, I just lose the negative, etc. If you're absolutely perfect every time, and you can skip this step that you see that I've got this fill in, then go ahead and skip that. But if you struggle with this at all, I'm telling you, this is the foolproof method. If you do this, you're going to have no trouble solving a quadratic equation with a quadratic formula. You'll get it right every time. We're on the step 3, fill in the values into the formula. And to do that, I'm going to replace the B with -3. I'm going to replace the A with +3. And I'm going to replace the C with -4. And now it's just simplify or solve. Be careful as you do this part. Just use the calculator to guide you and pay attention to each part here. But the opposite of -3 is 3. -3 squared, that's -3 times -3, so +9. A negative times a negative is going to come out positive. 4 times 4 times 3. That's going to be the same as 12 times 4, or 48. Use a calculator if you need to. 2 times 3 is 6. 48 plus 9 is going to give me 57. All over 6. Now that square root of 57 doesn't simplify, so I'm actually done here. Other than writing the answer, x is equal to 3 minus square root of 57 all over 6, or 3 plus the square root of 57 all over 6. Notice that here to the left there's another example done as well. You could use both of those examples to guide your learning. Let's try one more example of the quadratic formula. I'm going to start by writing the formula, and then I'm going to call out what a, b, and c are. A is 1, the coefficient of x squared. B is negative 6, the coefficient of x. And c is the constant, 10. The third step is to fill those values in. So in place of a, I'll put a 1. For b, I'll put negative 6. That shows up twice. And then for c, we've got 10. Oh, and I skipped one of the a's. A is 1. So I could double check. B is negative 6. B is negative 6. Minus 4. A is 1. C is 10. All over 2 times A is 1. So it looks like we're good to proceed. Now I'm going to simplify this. We get 6 plus or minus the square root of 36 minus 40 all over 2. Now I'm going to simplify this further, and then I'll have to simplify the radical also. 36 minus 40 is negative 4 all over 2. Now off to the side, this negative square root of 4, it's like a negative 2 times 2, right? So I can pull that a 2 out of the radical. This square root of negative 4 is equal to 2 times the square root of negative 1, or in other words, 2i. So I have x equals 6 over 2 plus or minus 2i over 2. And do you see what could be reduced? Do you see that 2 goes into 2 once, 2 goes into 6 3 times, and then 2 goes into 2 once, 2 goes into 2 once. So this 2 over 2 reduces to 1, 6 over 2 reduces to 3. So I've got the x equals 3 plus I, or x equals 3 minus I. It's 3 plus or minus 1i. That's it for that problem. I've solved it. This next set of problems is doing something even a little more basic, not doing the whole formula, but looking at what we call the discriminant. We can look at this part that's in the square root. So if I do the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac, right? That's the part of the formula that has a square root. So what I can say then is the discriminant is this b squared minus 4ac. Why is that the discriminant? That's the part that discriminates between whether we're going to get 2 real answers, no answers at all, or 2 imaginary answers, and so on. So the discriminant tells us what type of answers and how many answers we're going to get. When the discriminant is 0, if the b squared minus 4ac is 0, we would get 1 real solution. When the discriminant is positive, we would get 2 real solutions. And when the discriminant is negative, we'd have no real solutions. There are imaginary solutions that are complex conjugates of each other in that case. Let's go ahead and look at this. To start with, the formula is b squared minus 4a squared, or 4ac. So I'm going to pull out, just like I did before, I'm going to pull out the a is 1, b is negative 2, c is 1. And when I plug those in to b squared minus 4ac, it looked like this. The a is 1, the b is negative 2, so negative 2 squared, and the c is 1. Negative 2 squared is 4. 4 minus 4 is 0. So what that tells me is that since the discriminant is 0, there's 1 real rational solution. And that 1 real rational solution is repeated. It doesn't tell me what the solution is, but it tells me to look for 1. Let's try it again. If we do the next example here, I'll write the formula, b squared minus 4ac, and I'm going to call out what a is 1, b, and c are equivalent to from this example, and then I'm going to plug them in. So I've got b squared minus 4 times a times c. So in place of b, I've got negative 4. In place of a, I've got a 1. And in place of c, I've got a negative 5. When I multiply those, negative 4 squared is 16. Negative 4 times 1 times negative 5 is positive 20. So we get a 36. That's positive. So because that's positive, the discriminant is positive, I know that there are 2 real rational solutions. Because it's positive and because it's a perfect square, even better, I know that both of those solutions are rational even. But we get 2 rational. If it wasn't a perfect square, we'd know that we have 2 real solutions, but they might not be rational, meaning we might or might not be able to write them as a fraction. One more, b squared minus 4ac. And, I'm going to stop here. I'm not going to do this example all through. But if you let a equal 4, b equals negative 2, and c equal 3, you should get the discriminant is equal to negative 44. If you do this correctly, you should get a negative 44, which tells us that there are imaginary solutions, but there are no real solutions. Well, that brings us to one example that we could do a problem, an application problem we could model with a quadratic equation. To save some time on the video, I've written in some of the work here and did a highlight. What we're doing here is we've got this formula, the number of fatal crashes, F, for drivers of age X are modeled with this formula. And if we jump to the question, it says, what age groups are expected to be in 3 crashes per 100 million miles driven. So we can see that F is the number of fatal crashes and X is the age. And the question is asking us to find what age group. So let's find X when the number of fatal crashes, that's F, is 3. So if we let f of x equal 3, or just f, we didn't want to write this in function notation, if we use the equation as they wrote it, we're going to let f equal 3 and find x. So it'd look like this. 3 equals 0.013x squared minus 1.19x plus 28.24. And I want to solve that for x. You know, the easiest way to do that is going to be to start by setting it equal to 0. So I'm going to subtract 3 from both sides. So I'm going to get 28 minus 3 is 25.24. And now you could apply the quadratic formula to solve this equation, and then you could round it to the nearest age. And what you should get is that the two x's would be 33 and 58. If you solve that correctly, you'd get x equals 33 or 58. So we could fill that in to say that the age groups expected to be in 3 fatal crashes are those who are 33 years old and those who are 58 years old. Well, I hope these videos, a series of videos about quadratic equations, has helped you. I did drag it out a little bit longer for some of you, because maybe some of you find some of the prerequisite material pretty easy, but I didn't want to take any shortcuts. Feel free on videos to fast forward through the parts that you feel like you have a really good grip on, and then watch the videos more closely when it's something you do really need your full attention to, like the review of factoring or review of adding integers, etc.